Good morning. February the 1st, so January is now over. And I want a couple of announcements. I need to make a couple of announcements here at the beginning. You have WebAssign homework due February the 4th. And let me point out that now the grace period has expired for WebAssign as of yesterday. And so you need a access code in order to continue on with WebAssign. Don't worry that if you haven't done it yet, if you just can get an access code in the next few days, none of your previous work in WebAssign is lost or anything. So don't worry about that. It's just that you won't be able to continue on with WebAssign until you've gotten an access code. So please see if you can take care of that as quickly as you possibly can. Also remember that I dropped the 4 lowest WebAssign grades at the end of the semester, so you have a little bit of leeway there in that you can afford to miss a few grades and it won't hurt your average at the end of the semester. Exam 1, I've been talking about this now over the last couple of days in lecture. The window for Exam 1 is February the 8th through the 13th, which extends over a weekend. The Exam 1 review, a couple of you and I were just talking about that a second ago, is posted, and so be working on the Exam 1 review. All the worked out solutions to the problems are also part of the review, so you've got all of that to fall back to. And lots of problems on that review, so lots and lots of practice is available to you. I will be on campus next week. I'm always on campus 2 days before each exam window. And so I'll be on campus February the 7th and 8th, February 7th from 4 to 6, and February the 8th from 9 to 11. Remember, I'm on the North Harris campus, and my office is Winship 115K. So don't hesitate to come by if you have questions. I'll be happy to help you out face to face. Online hours. Today I'll be online from 11 to 12 for office hours. Please note on Sunday, usually my hours on Sunday are 8:30 to 9:30 in the evening, but to give everybody the opportunity to watch the Super Bowl if they want to, and also come and talk to me on Sunday, I'm going to not have hours in the evening on Sunday. Instead, I'll be online 12 to 1 Sunday afternoon. So don't hesitate to come by on Sunday afternoon from 12 to 1 if you have questions. I'll have my online office open then. And then next Tuesday, I'll be online from 11 to 12 and 8:30 to 9:30, same as always. One other thing that I don't have written here, but that I want to mention, and I don't remember if I've been mentioning this or not, but I do not live lecture during the testing windows. So you will have live lecture next Tuesday, and so that's February the 6th. So, let me write that out here. So February the 6th, we will have live lecture as always. But then on February the 8th and on February the 13th, that's a Thursday and a Tuesday, right? On those 2 days, no live lecture, because I will, that is during the testing window, and it's also, on the 8th, for example, I'll actually be on campus at that particular time of the day. So no live lecture on those 2 days, and then we'll just pick up again on the 15th and proceed on. So I never post live lectures during the testing windows. So, and finally, today we're going to push on and look at sections 8.3 and 8.4. We've started talking about rational expressions last time, and we were talking about multiplication and division and simplifying. Today we're going to look at adding and subtracting rational expressions, sections 8.3 and 8.4 of your textbook. So with all of that in mind, then let's get started and let's talk about addition and subtraction. And by the way, this is where Exam 1 ends, is with sections 8.3 and 8.4. I will move on to section 8.5 next Tuesday, during live lecture next Tuesday. That material will not be on Exam 1, that will be on Exam 2. All right, so Exam 1 stops with what I do today. All right. So please, as I'm going through this today, I know students have trouble with addition and subtraction, in particular with rational expressions. That's not uncommon. So please, if you're listening live today, don't hesitate to stop me, and I will be happy to go back over something again as we're going through this. So first of all, rational expressions. One more time, don't forget what a rational expression is, and I'm going to be reminding you of this because I want you to know the terminology that an algebra student uses. You're certainly going to be confronted with that in college algebra and in any math class you take after this one. So rational expressions, remember, are fractions, but they are particular kinds of fractions. They are fractions where the numerator and the denominator are polynomials. Right? It's a polynomial divided by a polynomial over a polynomial. And so last time what we did is we talked about simplifying and then multiplying and dividing. So remember, we have the equivalent fractions property that so the equivalent fractions property is something we stated last week, but it drives a lot of what we do when we're dealing with rational expressions. So the equivalent fractions property, remember, says that A times B over C times B is just equal to A over C. Right? And so one thing that allows you to do is it allows you to divide out common factors. So we saw that last time when you had simplifying a rational expression, and so like if we had just simply 8x squared over 10x cubed, right, we knew we could eliminate a common factor between the numerator and the denominator. The common factor in this case is 2x squared. Right, I can rewrite both the numerator and the denominator with the 2x squared as a factor. In the numerator, that would be times 4, and in the denominator would be times 5x. Right, and so we can divide out that 2x squared there, and we're left with 4 over 5x, like that. So the equivalent fractions property allows you to simplify a rational expression, but it also allows you let's see, now let me write that, simplifying a rational expression. So that equivalent fractions property allows you to do that. But then it also allows you to change a fraction, change the way a fraction looks. And so if you're given a fraction, let's just say I have 3 over x plus 5, and a typical rational expression, then you could always take 3 over x plus 5 and using the equivalent fractions property, multiply the numerator and the denominator by the same number. I'm just going to take 2 out of thin air there, and you could multiply numerator and denominator by 2. Right? As long as and what is the equivalent fractions property basically saying? That whatever you do to the numerator, you have to do the same thing to the denominator. And whatever you do to the denominator, as far as multiplication, you have to do the same thing to the numerator. So you'd be allowed to multiply numerator and denominator both by 2. Right? That would be allowed there. And then, so then you'd have 6 over 2 times x plus 5, like that. And so you've changed the way the fraction looks. Right? And so that this is something you always are allowed to do with a fraction algebraically, is you are allowed to multiply the top and the bottom by the same number and change the way the fraction looks, right? And so, I took 3 over x plus 5 and I multiplied by x minus 1 over x minus 1. As long as I do the same thing to the numerator and the denominator, that's legal algebraically, right? And so in the denominator, you have x plus 5 times x minus 1. In the numerator, you just have 3 times x minus 1. Right? So those things are legal algebraically. All right, so so what we're going to do now is we are going to kind of use those things to our advantage to look at adding and subtracting rational expressions. Now, also, don't forget that with multiplication, we've seen that to multiply two fractions together right, that you just multiply the numerators and multiply the denominators. The denominators do not have to be the same in order for you to do that, right? And let me kind of change the way that denominator looks so it looks a little nicer, like that, right? And so you're allowed to multiply numerators and denominators together, right? The denominators don't have to be the same. And same thing with division, right? With division, we saw that if you had A over B divided by C over D, that you inverted and multiplied, or leave, change, change, right? You changed the fraction to a multiplication problem and then just proceeded on with it as a multiplication problem, like that. But in both cases, the denominators did not have to be the same in order for you to multiply or divide. Well, with addition and subtraction, really different, right? Addition and subtraction, you must have the same denominator. So let me write addition, subtraction. Denominators must, absolutely must, be the same. All right. So the denominators must be the same in order for you to add or subtract. So if the denominators are the same, so if you have A over B plus or minus C over B, like that, right? The denominators are equal there. Then remember, the idea here is the denominator stays the same and you're just adding or subtracting the numerators, right? And so when the denominators are the same, you just add the numerators together. So that, it should be no big deal. So now I am on page 921 in your textbook. This is section 8.3, and I want to work a few examples there. Section 8.3, the denominators in these fractions are all the same thing. So let's look at what happens there. So we'll start off with something pretty straightforward, and then we're going to work our way up to problems that are not so straightforward. So here, if we just have 4 over 21 plus 3 over 21, right? When you see an addition problem, what's the very first thing you look at? The very first thing you look at are the denominators. Let me erase that right there. Let me put addition, right? As soon as you see it's addition, then you're saying look at the denominators. Right? Are they the same? That's your first question to yourself. And so in this case, the denominators are equal to each other. And so what do? I just leave the denominator alone as 21 and I add the numerators. 4 plus 3 and I get 7. Now the thing you got to remember on these problems is you can't just leave it like that. You do have to simplify. You always simplify at the end. And in this case, I could divide out as 7 and I'm left with 1/3. Right? So always simplify at the end. Always simplify as your last step. Right, and that is something you will get penalized for. All right, so that was problem 130. So now if we go on to like 134, you have 3c over 4c minus 5 plus 5 over 4c minus 5. See, so the denominators there, it's an addition problem, but the denominators are the same, so no big deal here, right? You just write out the denominator and then add the numerators together. Now in the numerator, you have 3c plus 5. Those are not like terms, and so you can't add those together. I see all of a sudden I'll see students going crazy and doing crazy stuff there, and like adding 3c and 5 together and getting 8c or something like that. So make sure that you only add together like terms when you're adding the fractions together. So this is the simplified version right here. There's nothing I can do with that beyond that problem right there. So, kind of keep that in mind. All right, problem 146. So I'm just working through examples now. We're talking about different issues that occur when you are looking at an addition or a subtraction problem. And so this problem, you see subtraction. right? And so you look at the denominators right away. The denominators are equal. And so I can subtract these two because the denominators are equal, right? The denominator stays z plus 2, and in the numerators, I just subtract them, and I get z squared minus 4. Now remember what I said, you always simplify as your last step. So after you've subtracted or added, then you go through and make sure there's no factoring you can do, and make sure there's no common factors in the expression. And in this case, there is a common factor, because the z squared minus 4 factors is the difference of squares, right? It's a squared minus b squared. And let me write that down, that it's a squared minus b squared. And because it factors as z plus 2 times z minus 2, notice I do get a common factor of z plus 2. And so the z plus 2's do divide out there using the equivalent fractions property we talked about a few minutes ago. And so that gives me z minus 2 technically over 1, because the only other factor in the denominator canceled, so you're left with a 1 there. Typically, you do not write the 1 in the denominator. You just typically write this as just z minus 2. If you wrote it z minus 2 over 1, I would absolutely not penalize you for that. But WebAssign might have some difficulty with that. So that's something you got to be careful about. And usually when there's a 1 in the denominator, I just wouldn't write it at all. All right. So the next problem, this is number 150. You have d squared over d minus 9 minus 6d plus 27 divided by d minus 9. All right, so now this is a subtraction problem. I look at the denominator, and the denominators are the same, so I know I can subtract them. But this second numerator here, notice, has several terms in it. When you have several terms after a subtraction problem like that, this is a place that you could screw this up with a sign. Easy to make a sign mistake when you have several terms and it's a subtraction problem. And so what I sometimes will do is I'll get students to identify these in particular when they see that subtraction with several terms after it like that, and kind of try to warn themselves that that's happening. And so I call these red flag problems. There's my red flag right there. And so this is what I call a red flag problem. And I actually draw a red flag because I know that there's a place here where I could make an easy mistake and mess up the signs here. So when I write this down right here, this is wrong, what I'm writing down. And so let me write that down, that that's wrong. I've made a mistake in that term right there. And the mistake is that when I'm subtracting, I am subtracting 6d plus 27, the entire expression. But when you write it the way I just wrote it right there, that person is only subtracting the 6d and not the 27. You're subtracting the entire expression there. And so you have to put that in parentheses like that in order to identify the signs correctly. This is correct right here. Right, and so you notice where I put the parentheses around the 6d plus 27 because I am subtracting the entire expression. And so when I do that, you distribute the minus sign through, and notice that changes the signs on both terms. Right, and so you have minus 6d minus 27 over d minus 9, like that. And so notice both signs ended up changing there, and but the student who wrote that incorrectly, right, they only changed the first sign but not the second sign. Right, so the second way is correct. I want to make sure that you know that the first step I wrote, that this is incorrect right here, but I want to leave it in the notes because I want you to really see what's going on here and why that's a mistake. All right, remember then, simplify at the end once you've got to this point. So I still need to see if there's anything I can eliminate here as far as a common factor. So the numerator does factor as, let's see, I have d's and d's there. This is going to be d minus 9 times d plus 3. And in the denominator, I've got d minus 9. And sure enough, the d minus 9's divide out using the equivalent fractions property that we talked about. And so this is just d plus 3, technically over 1, or just d plus 3. All right, so identify that these red flag problems and make sure that you keep the signs straight when you do that. I actually have students who will actually draw red flags on these kinds of problems on their tests, or at least they'll draw a little flag of some type. They don't have a red pen with them, and they'll actually identify it that way. Right? Those students who do that usually get these right because they are being careful about it. So, all right. So let's see. Let's move on to next problem I want to look at is number 156. So notice right now all we're doing is dealing with problems where the denominators are the same, right? And this is the easier situation. When the denominators are different, the problems get more challenging. And notice there's enough to worry about even when the denominators are the same. All right, so this problem's a subtraction problem, right? It's a subtraction problem, and there's several terms there. And so what do we have here? This is an example of a red flag problem, right? Where I'm going to mess the signs up if I'm not careful in this problem. So you've got to write this out like this in this step. You have 7t squared minus t minus 4, and then you're subtracting the entire second numerator, and so you put that entire expression inside parentheses like that. Right? That way you know that you've got to change those signs when you do this next step, right? That negative sign is like that there's a -1 there, and you're multiplying through by -1. So that's got to be careful. So you have 7t squared minus t minus 4, and then minus 6t squared minus 2t plus 1. See how I changed all of the signs on that second polynomial. Every term changed signs because of that -1. And then in the denominator, I have t squared minus 25. Okay, and then, now that you've taken care of that aspect of the problem and avoided that little pitfall, then you go through and you collect like terms. Be careful here to only collect like terms, right? Don't start adding things together that are not like terms. So 7t squared minus 6t squared would be t squared. And then -t minus 2t would be -3t. And then, let's see, -4 plus 1 would be -3. Let's see, did I make sure I did all that correctly there? All right, so I think we're good. All right, so you end up in the denominator with t squared minus 25 still. All right, so now the denominator does factor here. I can factor the denominator as t plus 5 times t minus 5, but notice the numerator, it doesn't. There's nothing you can do to factor that because there's no way you're going to use that 3 to have two factors that add or subtract to give you 3, right? So that numerator is not factorable in this problem. And so that's it, right? You've simplified the fraction. And in this case, since there were no common factors, either one of these last expressions would have been acceptable here. I would not have had a problem with either one of them. All right. So now any questions so far? Anybody have anything that they want to ask about?
No questions.
All right. Everybody's okay? All right. Then the next problem I want to look at, this is number 158. We want to gradually start talking about denominators that are not the same. Now this is sort of sort of, denominators are sort of not the same and sort of the same in some way. So in this case, notice that the denominators, 5d minus w, 5w minus 2 and 2 minus 5w, that the denominators are opposites. The denominators are opposites. And remember what opposites are. We've talked about that in the last lecture. Opposites are two factors that look like this. One of them is a minus b, and the other one is b minus a. When you have two factors that look like that, then you've got factors that are opposites of each other. So in this case, the denominators are opposites. And so you can easily make the denominators look the same by just multiplying one of them by -1. Now, if you multiply one of them by -1, so like, and usually I do the second one here, I'm going to multiply that one by -1. Now remember, you are not allowed to do that unless, and you remember what the equivalent fractions property tells you you have to do, that if you multiply the denominator by something, that you have got to multiply the numerator by the same thing, right? And so you have to multiply the numerator by -1 also. So you must multiply both the numerator and the denominator by -1. Right? Through the equivalent fractions property says you have to do the same thing to both the numerator and the denominator. That is a rule, right? When you're talking about changing a fraction, that is something you've got to live with. So what do you have here? You have 20w over 5w minus 2 here plus, and then what happens here is, in the numerator, when you multiply through by -1, right, that's -5w minus 6, because it's the distributive property. And think about the denominator now. You have -1 times 2 is -2, and -1 times -5w is positive 5w. And if you look at that fraction, or that denominator in particular, well, that is just 5w minus 2. It's just written backwards is all it is. That's just 5w minus 2. And so what happens when you multiply by -1? If the denominators are opposites and you multiply one of them by -1, then you're making them look the same. And so now we just proceed on with the addition problem. Now the denominators are the same, and you just add the numerators. So you have 20w plus -5w minus 6. Or you could have just written minus 5w also. And so that gives you 15w minus 6 over 5w minus 2. All right, now are we done with that problem? And for those of you who are listening live, are we done? And don't you know that when a math teacher asks you, are we done with the problem, that almost 100% means that you're not done, right? So the answer should be, no, we're not done. You know, that would be the only reason I'd be asking that question, are you done yet, is that we're not done. And I want to make sure that you realize that. So Tricia, we're not done. What do we have left to do?
We have to factor out the the 15 and the 5.
Well, okay, wait a minute now. Remember, I can't divide out the 15 and the 5 because I've got subtraction there. But the factoring is exactly what we're talking about. And Sandra identified this on with the chat message also. So you are right that we have to factor, that what we've got to do is the numerator has a common factor of 3. So you can take, remember, if the numerator or the denominator actually factor as polynomials, you have to factor them. So I can take out a GCF of 3 in the numerator, and notice what you're left with is 5w minus 2. And so then what happens, the 5w minus 2's divide out. I had a common factor, and then that leaves me with 3. Technically 3 over 1, but I'll just write it as 3.
3 over 1 or 3 over -1?
Well, the -1 is gone. Right?
Okay.
Yeah, because I multiplied by -1, so that's no longer an issue in the problem anymore. After I've multiplied in that step right there, right, then then I don't have to worry about the -1 anymore, right? Because I've multiplied both of the factors by that -1. So, all right. So let's see. Let's look at one last problem, and with the denominators being kind of sort of the same, and then we're going to start looking at problems formally where the denominators are not the same. So this is problem 162. We have a squared plus 3a over a squared minus 9. And then this is minus 3a minus 27 over 9 minus a squared. And so notice the denominators are opposites again, right? That's what we're looking at there. And the denominators are opposites. And so you need to kind of pay attention to that. When that happens, then you can make the denominators look the same by just multiplying this second fraction by -1 over -1, right? And so what's going to happen here when I do that? The first fraction, obviously, I'm not messing with that one, so I just leave that one alone. And in the second fraction, the 9 minus a squared, when I multiply it by -1, that turns that into an a squared minus 9, right? It changes the sign of both terms, and it just makes it look like the first denominator. And then in the numerator, you're using the distributive property, so that's just -3a plus 27 right there. All right, and now this is now the denominators are the same. Now the denominators are equal, right? Now the denominators are the same. And so now I can just treat this as a subtraction problem. This is a red flag problem. And so I make sure that I put that second numerator in parentheses like that. Right, so this is our red flag problem. And then I get a squared plus 3a, distribute that minus sign through, and that's plus 3a minus 27. And that's all divided by a squared minus 9. And then go ahead and add like terms together in the numerator, right? Simplify that way. And then remember, this is where I'd ask you, are we done yet? But we're not because, again, the numerator and the denominator are factorable. And because they're factorable, you want to do that and see if there's any common factors. In the denominator factors a plus 3 times a minus 3. It's the difference of two squares. And in the numerator, that trinomial, that's an easy trinomial, right? So you're just looking for factors of -27 that add to give 6. So it'd be a plus 9 and a minus 3. And so what happens there, the a minus 3's divide out. And so because they're common factors until you're left with a plus 9 over a plus 3. And remember at the end, the a plus 9 over a plus 3, the 9 and the 3 are terms. They're parts of addition problems. And so I cannot divide those out. And so that's in simplified form right there. There's nothing I can do to simplify that fraction any further. All right, so we've tackled the issue where the denominators are the same. And so now what we want to do is look at what happens when the denominators are different. All right, so let's start off. So we're looking at different denominators now. So as an example, let's look at 3 over 5x plus 7 over 9y. All right, so 3, that's right, the denominators are not the same here, and so I must build what we call a least common denominator. Build an LCD. Right, you're trying to build a least common denominator. And so when you build an LCD, you're talking about the number or the denominator that is the smallest common factor between 5x and 9y. And so you actually, I'm talking about building it. We actually build it. And so the way we build it is we build it using factors. And you're using factors from the denominator. So now look at the 5 and the 9. What's the smallest number that 5 and 9 both divide into? Anybody want to guess? What's the smallest number they both divide into?
1.
No. You're answering the wrong question. You're saying what's the number that divides into both of them? That's not what I asked. I asked what number do they both divide into? So like 5 divides into 10, and it divides into 15 and 20 and 25 and so on. 9 divide. Go ahead.
45.
45. That's right. Yeah, 45. Very good. That is the smallest number that 5 and 9 both divide into. And so 45 has got to be in our least common denominator. And then you go through all the variable factors, and any variable factor that you see in a denominator has got to be in the LCD. So I see an X, it's got to be in the LCD. I see a Y, it's got to be in the LCD. Right? So my least common denominator is 45XY. And so what we're doing, and I'm going to do a little bit of scratch work here, what we're doing is we're taking 3 over 5x, and we want to multiply the top and the bottom by the same thing so that I have a 45xy in the denominator. Right? You're trying to multiply top and bottom by the same number. And then you want to do exactly the same thing with 7 over 9y. 7 over 9y, you want to multiply top and bottom by the same number so that you end up with 45xy in the denominator. Right? And so you're trying to figure out what to fill those blanks in with. And it's easy to do. All you're doing, like with the numbers, with the numerical coefficients, you're simply dividing. 5 divides into 45 how many times? 9. And so I've got to multiply by a 9. With the variable factors, it's actually even easier to answer. With the variable factors, all you're doing is writing down any factor that's missing in the denominator, right? So like, here's my original denominator is 5x, and the new denominator is 45xy. So the variable factor that is missing is a y. And so I need a y there. And so I just multiply top and bottom by 9y. And I get 27y in the numerator there. You do exactly the same thing with 7 over 9y. Right? 9 divides into 45 5 times. So I know I'm going to multiply top and bottom by 5. And then the variable factor that's missing is x in this case. So I'm going to multiply top and bottom by x. And so this would be 35x right here. And so what I've done is I've changed the original problem so that it now looks like this. 27y over 45xy plus 35x over 45xy, like that. Right, this problem right here is equivalent to that one right there. Because all I did is I just took each fraction and I changed the way it looked by multiplying the top and the bottom by the same thing. But I did it in such a way that the denominators I ended up with were exactly the same. Tricia, what's your question?
Okay, so I might have missed something. When you changed the when you multiplied by the LCD.
I didn't be careful. I did
not by the LCD, but when you changed the variable.
Okay.
Why did you change the let me see if I'm getting this right.
Okay, so look.
Rotated the variables.
Let me show you. Let me show you again. Let me walk through the steps here. So we built our least common denominator, which is 45xy. That number right there, 45xy, is the smallest number that both 5x and 9y divide into. But both 5x and 9y divide into 45xy so that you don't have any fractions left over at all. So that's what I want to change my denominator to. Notice this is what I'm putting in purple, what I'm highlighting, that's the old denominator right there. And what I want to do is I want to change that into the new denominator. And you're doing the exact same thing to both fractions. You want to change both of them from the old denominator to the new denominator. Like that. Right? And so what you got to do is you got to figure out what to divide, what to multiply by to get that. Now, what you could do, I didn't write this out. I said it, but I didn't really write it out. You could take the new denominator, 45xy, and you could divide it by the old denominator, 5x. This is the new denominator right here. This is the old denominator. Always take new and divide it by old. So what happens when you take the new and divide it by old?
So the x is out. Okay, that's what it.
Yeah, the 45 and the 5 divide out, leave you with a 9. The x's divide out, and you're left with 9y. And so notice that is what I multiplied by right there, is 9y over 9y. You do the same thing with the other fraction. I take the old denominator, the new denominator, and divide it by the old denominator. So 45xy divided by 9y. And so the 45 and 9 divide out, leave me with a 5. The y's divide out altogether, and I have 5x. And so notice that's what I multiplied by on that one, is 5x over 5x. And if you want to write that out at the on each of these problems, that is absolutely not a problem at all to do that. So, all right. So Tricia, good. I'm glad you're looking at that, and good question to ask about there, because that's the critical step in the whole problem. So, and so let's see if this next one works out a little bit better. So let's say we have 2. Whoops. Let's see. Let's not make that a 2. Let's change that numerator to a 5. Let's say we have 5 over 6x cubed y minus 7 over 8x y cubed, like that. All right, so what we've got to do is we've got to build the LCD first. We do that off to the side. Build the LCD. And so now we need the smallest number that 6 and 8 both divide into. Now don't tell me that it is 2, because 2 divides into 6 and 8. I understand that, but I'm asking what's the smallest number that 6 and 8 both divide into? So what would that be?
24.
Okay, good. So 24 is the smallest number they both divide into. And then in the LCD, you also have an x as a variable and a y as a variable in the denominator. So you've got to put both an x and a y in the LCD. And then they are raised to powers. You always raise them to the largest power you see in the original problem. So notice the x and the y both get raised to the third power right here. 24x cubed y cubed is the LCD. So now what could you do? Remember, that's our new denominator. You're going to take new and divide it by old. If I could spell the word old, that would be good. And so you take the new and divide it by the old. So let's see, I take 24x cubed y cubed and divide it by 6x cubed y, and what do I get? What do I get there? Anybody?
4y.
4y.
Because
4y to what power? What would the y to? What would be the power on the y?
Square.
Good, very good. So you have 4y squared. And see, so that's what you're going to multiply the first fraction by. Right? The first fraction is 5 over 6x cubed y. And so you're going to multiply that one by 4y squared over 4y squared. And then the second fraction, you take 24x cubed y cubed, take new denominator, divide it by the old denominator, and what do you get there? Anybody? So 24 divided by 8 would be
3x squared.
3x squared. There you go, right? X cubed divided by x is x squared. Very good. And so the second fraction, let's see, 7 over 8xy cubed, I'm going to multiply that one by 3x squared over 3x squared, right? That gives me what I'm multiplying by. And remember, whatever you do to the numerator, you have to do this, or whatever you do to the denominator, you have to do the same thing to the numerator. Now, what will happen in the denominator, I'm going to get the LCD, 24x cubed y cubed there. And in the numerator, I get 21x squared for that one. And then in the first fraction, the denominator, again, is 24x cubed y cubed. In the numerator, in this case, it would be 20y squared. All right, and so then I've changed both fractions, and so now this is my new problem now. It's 20y squared over 24x cubed y cubed minus 21x squared over 24x cubed y cubed. Right, and so the denominators are now the same. I can combine the fractions. Now be careful, the numerators are not like terms. One of them's a y squared, one's an x squared. So there is nothing to do there. I see students all the time trying to force subtracting those, but there's nothing you can do to subtract those. They're not like terms. And so that's it. You're done. Right? There's nothing else left to do to simplify that. All right, so now the next couple of problems I'm going to look at are not going to look quite the same as the ones we've been doing. But it's exactly the same kind of problem, but not powers of variables in the denominators in a lot of these. So next problem I'm looking at, let's see, this is number 194. And this is 4 over, and they have s minus 7. My s's look too much like my 5's. So I'm going to change it to x minus 7 plus 5 over x plus 3. All right, this problem is actually a lot easier than the last couple we've done if you are kind of work through it like we've done with the last step. So the first thing you're going to do is build the LCD. Now be careful. In the first fraction, the x minus 7 in the denominator, well, the x is not a factor there, and 7 is not a factor. It's x minus 7, that's the factor. And x plus 3 is the factor. And so my LCD, remember, you've got to have all the factors that you see in the LCD. It's just going to be x minus 7 times x plus 3. And then remember, you take new divided by old. So I take x minus 7 times x plus 3, and I divide it by the first denominator, and what do you get? The x minus 7's divide out, you get x plus 3. That's what you're multiplying the numerator and denominator by on that first fraction. Right? You're taking 4 over x minus 7, and you're multiplying top and bottom by x plus 3. And then on the second fraction, you take the new denominator, the LCD, and divide it by the old denominator, x plus 3. And what happens? The x plus 3's divide out, and you're left with x minus 7. And so what's that telling you? That's telling you to take that second fraction and multiply it by x minus 7 over x minus 7. Right? Remember, you have to do the same thing to the top and the bottom. And so what do you get here? You get x minus 7 times x plus 3 in the denominator for both of those, right? You should always end up with the LCD. And then the numerator, I would just use the distributive property there. So you get 4x plus 12 and 5x minus 35. right? So in some ways, that's kind of scratch work, what I just did right there. And so then you go back to the problem, and this is now your problem. Now, I do see students getting really hung up on these problems and trying to do as little as, or write out as few steps as possible. I have no idea why that's true. But my recommendation is to write lots of steps. Don't worry about taking up some room here. Your chances of making a mistake are greatly reduced if you write out more steps here. So what do I get? This is an addition problem, so now I just add the numerators, right? And the denominator stays the same, and then I'm almost done. I get 9x and then minus 23 over x minus 7 times x plus 3. So think about this. If you take a little bit more room, write a few more steps out, you probably increase the chances of getting the problem right by a factor of, I bet, 3 or 4 at least. All the time I'm seeing students trying to compress as much as possible and trying to do as much work in their head, and then they just make careless mistakes. Or these are longer problems, so they end up getting lost in the problem because they are actually longer problems. So take your time. It's not a race trying to get through this as few steps as possible. It's definitely not. All right, let's look at a subtraction problem. Let's look at number 212. So 212, we have x minus 3 over x plus 6 minus x over x plus 3. Like that. And so this is a subtraction problem, so I do know that it's a red flag problem, right? That I could screw up the signs if I'm not careful. So I draw that red flag there to remind myself to be careful with the signs as I go through the problem. All right, so now we do the LCD. Right, and so remember, in the LCD, I use all the factors that I see in any of the denominators. So that's an x plus 6 and an x plus 3. And those are the only factors in the denominator, so that's my least common denominator. And then you take the new denominator and divide it by the old denominator. And for the first fraction, the x plus 6 divide out, and I'm left with x plus 3. And on the second fraction, I divide by x plus 3. Those divide out, and I get x plus 6. So what is that telling me to do here? That's telling me that in the first fraction, I need to multiply numerator and denominator by x plus 3. And on the second fraction, I need to multiply numerator and denominator by x plus 6. Right? So, in fact, if you want to, I can color code that. Right? There's x plus 6 on that second fraction. Like that. Here's x plus 3 on the first fraction. Remember, you have to multiply numerator and denominator by the same thing. All right, so what happens here? In the denominators, don't multiply them out. Leave them factored. The denominator, never multiply it out because you're going to try to simplify at the end. And so you want it factored anyway. So just write it out as x plus 3 times x plus 6. And then in the numerator, you get, in the first fraction, you have x minus 3 times x plus 3. You could use the FOIL method to multiply that out in the numerator. In the numerators, you do want to multiply out because you want to collect like terms. But notice that when you multiply x minus 3 times x plus 3, that's just the difference of squares. And so the middle terms cancel out when you use the FOIL method there. And when, you could use the FOIL method, and the inside 2 would be negative 3x, and the outside 2 would be positive 3x. Those would cancel. So you just get x squared minus 9. In the second fraction, you would use the distributive property, and you get x squared plus 6x. let's see here. Got x squared minus 9, and I have x plus 3 times x plus 6. In the second fraction, I've got x squared plus 6x, and I've got x plus 3 times x plus 6. Now, I know it's a lot of work to write all these steps out, but it pays off at the end that you can get through the problem without making a careless mistake at all. So be careful. This is a red flag problem. So I put that second numerator in parentheses because I'm going to change the signs on that. And so I have x squared minus 9 minus x squared minus 6x all over x plus 3 times x plus 6. And then the x squares go away there. They add to give 0. So you're left with negative 6x minus 9 over x plus 3 times x plus 6. The numerator does factor. You can take out a negative 3, and you're left with 2x plus 3. In the denominator, you have x plus 3 times x plus 6, but nothing simplifies. There's nothing to divide out. So actually, either one of these answers right here would be sufficient. And because both of those are simplified form there. So, okay, so we had a little bit of an interruption there as my Apple Pencil died, but I think we're back together here. So I'm going to work another problem or two here. I think we'll get through 2 problems here, and then that will be it for the day, and we'll have finished up. So let's see. The next problem I want to look at. Let's look at problem number 220 out of this section. So you have 4 over n plus 4 minus 8n over n squared minus 16, like that. Now, you cannot build the LCD until all the denominators are factored. You cannot build the LCD until all denominators are factored. See, so there is a little bit of factoring to do in one of the denominators on this problem. And so you have 4 over n plus 4 minus, and then that second fraction, that factors n plus 4 times n minus 4. You have 8n. Okay, so the LCD, now we're ready to build the LCD. And you write down all of the factors that you see in any of the denominators. But I want you to notice, so that's n plus 4 times n minus 4. The second fraction already has the LCD in the denominator. So the good news here is that that second denominator doesn't need to be changed at all. And so the only one I need to change is that first denominator. I take the new denominator and I divide it by the old denominator. So I have n plus 4 times n minus 4 divided by n plus 4. The n plus 4 is divided out. I'm left with n minus 4. So that first fraction, that means that I'm going to multiply numerator and denominator by n minus 4. And in the denominator, you have n plus 4 times n minus 4. And in the numerator, use the distributive property. That's 4n minus 16. So the first fraction had to be changed. The second fraction was good like it was because it already had the least common denominator in the denominator there. And so the first fraction changes to 4n minus 16 over n plus 4 times n minus 4. The second denominator, I don't need to worry about that one. Or the second fraction, I didn't need to worry about it. It was okay like it was. And so now I've got the same denominators. Now I can go ahead and subtract these. Write them as one fraction. And you get 4n minus 16 minus 8n. And let's see. So I add the like terms together. So 4n minus 8n is negative 4n. minus 16 over n plus 4 times n minus 4. And like we've talked about, you simplify at the end, and so there is actually something to do here, because I can take out a negative 4 out of the numerator, and that leaves me with an n plus 4, and then the denominator of n plus 4 times n minus 4. So this rational expression actually does simplify, because I can divide out the n plus 4s. And so you are left with negative 4 over n minus 4. And that is my simplified rational expression there. Okay, so the new thing on this problem is you had to do a little bit of factoring in order to find the least common denominator. So, and you'll encounter that on this next problem also. And in fact, this next problem I think is going to be our last problem of the day. That will give us enough examples of every type that you're going to see. So this is number 238. You have 3p over p squared plus 4p minus 12 plus 1 over p squared plus p minus 30. And so remember, factor the denominators to find the LCD, right? So to find the LCD, factor all denominators first. You have to do that, or you're not going to be able to find the LCD. So the first denominator factors p plus 6 times p minus 2. Second denominator factors p plus 6 times p minus 5. Okay, so so now you go over and you build the LCD. You write down all the factors that you see, and you see 3 factors. Now the p plus 6, be careful, the p plus 6 is in both fractions, but it's only used once in each of the fractions, and so all I needed is once in the LCD. You raise it to the largest power you see in the original problem, but it's p plus 6 is raised to the first power in both of those fractions. And so my LCD's got 3 factors in it: p plus 6, p minus 2, p minus 5. All right, so you take that denominator, and a lot of you are not going to write this step out where I've been dividing, but what are you going to do? You're going to divide it by the first denominator, and you're taking the new denominator, dividing it by the old denominator, and what happens? The p plus 6's divide out, the p minus 2's divide out. You're left with p minus 5. So in that first fraction, I am going to multiply the numerator and the denominator by p minus 5. And what are you always doing there? You're multiplying by the factor that's missing in both the top and the bottom. Right? And so you have p plus 6, p minus 2, p minus 5. It really doesn't matter what order you write those factors in. Right? It's multiplication, so the order doesn't matter. In the numerator, just use the distributive property. So in the second fraction, this is my second fraction right here, 1 over p plus 6 times p minus 5. And the factor that's missing that is in the least common denominator there is p minus 2. And so you're multiplying top and bottom by p minus 2 right there. And if you want to, you could certainly go off to the side and divide to show that. Right? Here's the new denominator right here. And then here's the old denominator that you're dividing by. And what happens? You're left with p minus 2. So in the numerator, you've got p minus 2. And in the denominator, you've got these 3 factors. Like that. Okay, and so that's my new problem now. You could just add the 2 fractions together in a column right there if you wanted to conserve a step right there. I'm going to go ahead and write it out. I'm always a big advocate for writing out a lot of steps here and taking your time, not trying to race through the problem. Remember, my goal is to try to get you to be able to work through these problems correctly. My goal is not to get you to be able to beat other people and race other classes and get them done faster than everybody else with as little paper used as possible. That's not my goal at all. The people who race through these problems, try to conserve as many steps as possible, typically make mistakes. And so I'm trying to get you to avoid that. So now I've got the two fractions added together, right? I had the same denominator, so I'm adding the numerators, and then I collect like terms. Negative 15p and p is negative 14p. And there is no way that I'm going to get a 14 from that 3 and 2 like that. And so that numerator certainly does not factor. It's not factorable. And so that's the simplified version of this addition problem right there. All right, so, I've worked through quite a few problems now as far as addition and subtraction. These kinds of problems will be on your exam next week. So this is something you need to be working on, definitely. Does anybody have any questions that they want to ask about here?
No.
Questions?
Now, what's going to happen if, for a lot of you, if you, and I always have this conversation with students in a face-to-face class also, as I've gone through these problems, probably maybe the first couple were a little bit uneasy for you, but as I worked through them, that you probably got used to the steps if you were following what I was doing. And by the end, you're probably saying, okay, I kind of understand. I understand what he's doing. And now what happens? You don't go home and practice. When I say go home, but you're actually probably in your homes or apartments or wherever you are, and you're probably already there. You've got to practice now. You've got to follow this up with practice, because if you don't do anything at all and don't practice this, and then you come back to this next week as you're preparing for the test, then you're going to forget how to do this again. So now's the time to go back and practice as much as you can. The sooner you can do that to right now, the sooner you can do that to you actually seeing this lecture, the better off you are. Like I know, I believe with Taylor and Raina, both of you guys, I've gotten comments from both of you on WebAssign in the hour after you've had this lecture. So I know that you guys, at least sometimes, have just gone over and started doing the homework right away. And that's what you got to do. And the sooner you can get to the homework, and I know some of you are in a position where you can't really do that now. Like Sandra, I know, is at work, and so she's not going to be able to go and do the homework. But the sooner you can get to it, the better.
Now, is WebAssign the best way to contact you?
The best way to contact me, well, I've had students contacting me, like there's 4 different ways you can contact me, right? Because you can send a message through WebAssign. You can send a remind message to me. You can send me an email. You can show up at my online office hours. So all those different ways that you can get in touch with me. And basically, I'm checking all of them right now. So, I'm checking when I'm around, I get on my computer. The first thing I do is I go to Remind and check my Remind messages. I go to WebAssign and I check my WebAssign messages. And I try to return all those immediately. And then I'll go to emails and all that after that. So WebAssign and Remind are usually the 2 that I get to first. So.
Okay.
Like Taylor, I know you've done both of those. You've done Remind messages and you've also done WebAssign, though lately you've just been doing WebAssign and sending me messages. And I've been trying to respond to those, so hopefully you're getting those responses back. So,
yes, I've been getting them.
Okay.
Thank you.
Anybody else have a question or comment?
No?
Okay, so let me write down, I always do this at the end, let me write down textbook practice. These would be good problems to practice on this, and I know some of you don't have, this is kind of your lowest priority is textbook practice, but I really feel like these are problems that would be good for you to be looking at least some of these, even if you can't get to all of them, at least some of them would be helpful. So 145 through 159 odd on that page, and then on section 8.4, this is page 934, section 8.4. This is problems 185 through, and these are longer problems, so I would expect that you not be able to get through all of these certainly, but up through 243, and as many of the odds as you can do there, basically is what I'd say. Any of those would be good practice problems. So, all right. So remember, I have office hours, so don't hesitate to come by. Contact me if you have questions, and otherwise, hope to see you. I hope I'll talk to all of you sometime between now and our next lecture next Tuesday. If not, have a great weekend. Enjoy any Super Bowl festivities that you are partaking in on Sunday. Just be safe, and I will be in touch.
Thank you.
Thank you. You have a good one too.
Thanks. Take care, everybody.
Thank you.
Bye.